In this lesson, we are looking to simplify radical expressions, and we will need this later on when we do quadratics. So the order of the radical is the type of root we are using. If we see something like this, that is a square root because there is no number. So if there is no order, we assume it's a square root. If it's not a square root, it will let you know. So for example, cube root, we'll see a 3. So we're just going to work with square roots, but later on when we do exponents, we will be looking at different types of roots. So if radicals have the same order, meaning the same type of root, then we can just add or subtract terms just like they were variables. So we would just look for like terms. So in this question, I see root 3 and root 3 are like terms, so I'm going to add the coefficients. So 5 minus 3 is 2, and that would be 2 root 3. And then likewise here I see this is root 5 and this is root 5. Those are like terms, so I'm going to add the coefficients. 2 plus 7 is 9, and then root 5. So this would be kind of like adding 5x plus 2y minus 3x plus 7y. If we were adding these, we would add the coefficients. Oops, that's not a 12. But the variables would not change, so that is similar. So 5 minus 3 is 2, 2 plus 7 is 9. So similar to that, we treat these roots like terms, and we just work with the coefficients. Sometimes the radicals are not expressed in lowest terms, so we have something that is called an entire radical. So if it's not in lowest terms, it's called an entire radical, and we want to change it to a mixed radical. So it's kind of like an improper fraction changing to a mixed fraction. So what we want to do is you want to look for two numbers that multiply to get 18, where one of them hopefully is a square. So I know that 9 times 2 is 18, and I know that I can square root 9, but I can't square root 2. So I'll square root 9, which is 3. I can't square root 2. That would be a decimal. So as a mixed radical, it would be 3 root 2. So 98, I want to think of two numbers that multiply to get 98. So one is a square. So I know 98 is 49 times 2. I can square root 49. I can't square root 2. So the square root of 49 is 7. And that would be 7 root 2 as a mixed radical. 72 I know is 36 times 2. I can square root 36. I can't square root 2. So square root of 36 is 6, and then we would have root 2. So now when we're adding, subtracting terms, and they're not like terms, they might need to simplify them first before we look for like terms. So root 20 and root 45 are not like terms, so I can't do that. But I could simplify root 20. So root 20 is 4 times 5. I can square root 4, so as a 2, and then I just multiply the 3 and the 2, the coefficients, is 6 root 5. I'll do the same with the 45. 45 is 9 times 5. I can square root 9. I can't square root 5. So now that I've simplified them into mixed radicals, I can see that now I do have like terms, so I can add the coefficients. 6 plus 3 is 9, and that would be 9 root 5. So let's try with this one. 18 is 9 times 2. 50 would be 25 times 2. And 98 would be 49 times 2. So square root of 9 is 3. Square root of 25 is 5. Square root of 49 is 7. Then we'll just multiply coefficients. So 2 times 3 is 6. 5 times 5 is 25. And 3 times 5, or 7 is 21. So then we'll just collect. Now they're all like terms. They're all root 2s. So now we can just add these coefficients. So that would be 2 root 2. Negative 25 plus 21 is negative 4. 6 minus 4 is 2. If you are multiplying, whole numbers get multiplied, so the coefficients get multiplied, and then roots are the same, so roots get multiplied. So if I'm multiplying 2 root 5 times 2 root 2, I'll do the outside numbers. So 2 times 2 is 4. And then I'll do the inside numbers. 5 times 3 is 15. Then I'll do 2 root 5 times negative 5. So I'll do the outside numbers. 2 times 5 is 10. And we just have a root 5. And then we'll do 1 times 2 is 2, root 3. And then finally we'll do 1 times negative 5. And then I would look for like terms. I don't have any. Root 15, root 5, and root 3 are not like terms. I can't simplify root 15 because it's just a 5 and a 3. So then my answer is finished.